Yes.
Yes.
اوكي، 8 واي 8 times واي تحت بعد شوي تحت.
Yeah.
اوكي 0.073 من وين جبناه؟
0.073 is the value of y. Okay. And the value of y, look, because they gave you هيدي من table من جيبه. They gave you what's 1 second. Okay. Look, when they give you they tell you water at 20 degrees. Okay. From this information, you can go to the table of water properties, and for water at 20 degrees, you can find what is the value of y. Okay, so this is a value from a table you can get it. And concerning row of water, because they gave you the specific gravity of the steel needle, you have that. For this one, to find row of the needle, you do the specific gravity of water at 4 degrees, which is 998 kilogram per meter cube, times the specific gravity, which is 7.84. Okay? So this is how you find.
Okay. بس
So in general, if they don't give you the table, if they don't give you a table, you can go, they will give you the value of y. Okay? So, or they give you y in the given, or they will give you a table saying that surface tension for this is that. Okay? So, or you have the tables with you, or they give you directly the value of y.
Okay.
Just one other note, that for the person that was asking about surface tension at this level. So here in this problem, if you want, they already illustrated for you surface tension between this curve and the surface. If you want, you have surface tension here, but it's not coming from this curve. It's coming from another plane curvature. So if I want to illustrate this, if you take this profile of the cylinder, so if you look at it from this side, okay, from this side you will not see this curve of water. This curve of water, you will just see it from the side, from this view, and it will be along L and along L, okay? If you want to see the curvature for this side, it will be from the other side of water. So like this, if you want, this is water, and if I want to illustrate the curve, so it will be like this. From this side, you will have rise of water, and it will be tangent to the surface, okay? So here, in case D is very large, you should account for this effect. In general, they should be specific in the given. They should tell you, for example, they should tell you the diameter is very small compared to length. In this way, you will neglect the curvature created at this level, okay? And you will account only for curvature that is here and that you will obtain at any plane. If you do any plane at this level, you will obtain the same curve, okay? You will obtain this curvature. This is why the total length is 2L. However, if you consider the curvature from these two sides also of the center, then you should add to 2YL, you should add plus 2YD. But in general, when they don't give you any information, and they should be very specific in the problem, they should tell you D is small compared to L, so that you don't take it into account. Okay? Any other question on this problem?
Doctor, can you just repeat the last point that you were saying because the internet was lagging?
Okay, I will repeat. I am saying that in this problem, when we solved it, we just consider 2y times L. Because as you can see in the figure, they have drawn the surface tension forces that are tangent to the following curvature. Okay, so whenever you put your cylinder, the water will form curves around the cylinder due to its geometrical shape. Okay, so from this figure here, this curvature of the fluid is repeated over the total length of your cylinder. This is why when you want to calculate the total surface tension, you multiply by 2L, because this curvature is repeated in this pattern, in this way, at any point, at any cut of your distance L. Okay? Now, in general, to know that only you should account for these forces, they should tell you that the diameter is much smaller compared to L. If they don't tell you this, what you can add to the contact length is 2dy, but not from this curve, because if you look at the profile view of your cylinder, this is your cylinder, okay? You will not see these curves at this level. You will see curves in the perpendicular direction. So if you take a look at it, it will be like this. Water at this level will rise like this, okay? So you have another type of curvature that is formed on this plane, okay? And if you want to consider the total length on which this curve is applied, you will add 2d, because it will be applied on the diameter of the needle. This is d in this direction. In general, for the problem, it should be very clear if you should account for this or not. So they should tell you if they should, here for example, they just the forces along, okay? So this can help you to think that they want you to just consider these forces, okay? But in general, to be more specific, they should give you the information that D is much smaller to L, so that you can reflect the curvature that is formed at this level compared to the one that is formed along the cylinder length. Okay? Now we move to problem 8. During a mountain trip, it's observed that the water used to cook a meal boils at 90 degrees rather than the standard 100 degrees at sea level. At what altitude are the climbers preparing their meal? You should use tables B2 and C2 in order to solve this problem. Okay? Now, what should we do here? They told us that the meal is boiling at 90 degrees instead of 100 degrees. What do we understand by this? What is the information we can understand? That the vapor pressure at 90 at this altitude is lower, okay? Because as you go in altitude, as the altitude increase, so this is the altitude, okay? If you increase the altitude, then the vapor pressure of the fluid will decrease. Vapor pressure will decrease, okay? So they are asking us at what altitude we should be to have boiling at 90 degrees. In order to solve for this problem, we should first go to the first table, okay? The first table, which is B2, will give us what is the vapor pressure at 90 degrees. So since I have boiling at 90, I will go to my table and look at 90 degrees, okay? At 90 degrees, I can read that the value of the vapor pressure is 7.01 times 10 to the power 4 Newton per meter square, okay? So from this table, I can say that at 90 degrees, okay, my vapor pressure is equal to 7.01 times 10 to the power 4 times 10 to the power 4. okay, Newton per meter square. Now, how I will use this information to determine the altitude? I will go to the second table, okay? So I will go to table C2. In table C2, I will go to the column of pressure, okay? And I will read for this pressure what will be the altitude. I am interested in which value? I am interested in a pressure of 7.01 times 10⁴. So if I look in my pressure column, I can see that 7.01 lies between these two values. So it is between 6.166 times 10 to the power 4 and 7.012 times 10 to the power 4. So I can be sure that my altitude will be between 3,000 and 4,000. Okay? Now, because 7.01 is very close to 7.012, I can say that nearly the altitude.
Or we can interpolate.
Yes, if I want to be very specific, I interpolate. Okay? So if I want to do interpolation, I say that 7.012 times 10 to the power 4 Newton per meter square correspond to 3,000 meters, and 6.166 correspond to 4,000. So if I put in between, the value in between is 7.01. So how can I do the interpolation? I can say here that H should be between 3,000 and 4,000. So I can write the following equation. H
دكتور مش لازم تكون بين 2000 و 3000 او لا؟
لا لأنه
لا sorry between 6 خلاص مش
yeah, okay. So how to do the interpolation? It's very simple, as you do in thermodynamics. So it's H minus 3,000, okay, over 4,000 minus 3,000 is equal to the value of PV that we want, which is at H we have 7.01, so it's 7.01 minus at 3,000 it is 7.012 over at 4,000 the value is 6.166, so 6.166 minus 7.012. Okay, so this equation will give me my only unknown, which is H, and I will get nearly H equal to 3,002, which is very close to 3,000. So if you do the interpolation, it's nearly 3,002.364 meters.
دكتور
Yes.
بس هي هون مين قال لي انها linear؟
هي ما حدا قال لي انه linear, but it's an approximation. Okay, in general with tables we do linear approximation. It's an assumption. Okay. Guys, concerning Zoom, I'm really sorry, but we have the limit of 40 minutes. So I will see if I can buy a license, but another way I cannot have unlimited session.
ما فينا نستعمل ويباكس؟
أنا I am في عندي مشكلة بالrecording بالWebEx. I contacted the IT. Let me see if it's solved. If it's solved, we can use WebEx. يعني I can do WebEx session, but I cannot record. So whenever I solve the issue of recording, because the data, I don't know what is the problem. So the IT are updating the account. I don't know what. Okay. So whenever we can use it, we will. Okay, the last problem, problem 9. When a fluid flows through a sharp bend, low pressures may develop in localized regions of the bend. Estimate the minimum absolute pressure in psi that can develop without causing cavitation if the fluid is water at 160 Fahrenheit. So I just want you to know that whenever you have fittings like bands, okay, and we will see it in future chapter, how we calculate the pressure loss in bands. okay? And in many fittings, you have pressure drops. So whenever a flow is going over a sharp bend, we know that you will have a pressure drop across some zones, and this can cause cavitation. Why this can cause cavitation? Because the pressure will decrease, and if it will decrease below the vapor pressure, then we will have bubble formation, okay? And this is called cavitation in the flow, okay? So whenever they tell you what is the minimum pressure to avoid cavitation, you say that to avoid cavitation, the minimum pressure is what? Is the vapor pressure at this temperature, okay? So we can directly say that the minimum pressure to avoid cavitation is the vapor pressure at 160 Fahrenheit. And here, because pay attention for units, you are using English units, so you go to the English unit table, which is here table, you can find it at the end of your book. It's table B1, okay? Physical properties of water in English units. You go to the temperature of 160 Fahrenheit, so it's here, okay? And then you can read the value of vapor pressure, which is 4.736 lb per inch square. So this is the minimum pressure that we should not go below in order to avoid cavitation. Any question? Okay, guys, so if you don't have any more question, we can stop here.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor. Goodbye.
Bye.
Doctor,
Yeah,
Doctor, can you post slides of chapter 2?
they are already posted. If you go to the link I gave you for videos, you have the video of chapter 2.
We have the video, but we don't have the slides as a PDF.
You want the slides? Okay.
Yes, thank you.
So I can give you the link to the PowerPoint. You want the recorded PowerPoint or just the slides?
Just the slides.
Just the slides.
Okay. Okay, I will post the slides.
Thank you.
doctor,
Yes.
لحديد أي slide we have for Wednesday?
So you should listen to 1 hour and 30 minutes of the video. So you can see what is the corresponding slide. I will tell you on the WhatsApp group which slides you can.
Okay, doctor. Thank you.
Okay, welcome.